All right, so big difference today. What we're doing is we're going to be doing solving exponential equations, which still has a lot of some of the same things we've been doing, but there'll be a couple of new things that we'll kind of add into it. And some of this will look the same as what we've done the last couple of days. There'll be some parts of it that'll be new. So again, this is lesson number 25. We've got one more to go after today, and then that'll wrap us up for the year. So. All right, so here's the big thing with this one. And there's a couple of different ways you can do this. There's the way that the book says to do it, and there's another way you can do this one that after doing this a couple of years, the students, we've been working through this, and they're like, well, I think this is easier. So we'll show you both options and see what you can do. Here's what they said was easier for them. Basically is this. If you cannot solve an equation the way it is written, because it's either going to be in log form or it's going to be in exponential form. Basically, it's one of two options we're looking at. So if you cannot solve an equation the way it's written, if you look at it and you go, I don't know, then what you're going to have to do is you're going to have to rewrite it in the different form. And the way we're going to do this, because some of the forms that we do, the way we did the first couple of problems, the way we did some problems the first day was you had to kind of think your way through it, and come up with the answers just by thinking process. And then the second day, we showed you how to do it with a calculator. So we'll basically kind of do the same thing today, that we'll say, all right, well, here's the way you could think through this one. But if you'd rather not do this one, here's a way you can think through this one and use your calculator and kind of get there. All right, so first problem is we'll look at one like we did on the very first day of this one. We're doing this on Monday. If you got 2 to the x equals 16. Because what we did on Monday when we did this one, and this, again, this is the part that you don't have to do, but you could do this one. We went kind of through the powers of 2. 2 to the first would equal 2. 2 squared was 4. 2 to the third was 8. 2 to the fourth was 16. So finally, 2 to the fourth was 16, so then the exponent would have to be 4. Okay, that's the way you can do that. But sometimes people don't recognize that very well. They don't quite see that one. So here's what you can do. If you just turn around and rewrite this problem and put it in log form, base was 2, so it's log base 2. You switch these two numbers. And once you're here, now you can do like we did on Tuesday when we said, all right, well, here's how you can use your calculator. Now you can take out your calculator and just punch it in the calculator and get the number you need. So we're doing log of 16. Again, just make sure you close off the parentheses when you do this one, divided by log of 2. And we get to the answer is going to be equal to 4. All right, now, and depending on which calculators that you have, the Texas Instrument, this one doesn't have a log button that's set up like this one. On the Casios, it actually has, Casio is a little bit different, so I'll show you this one. If you've got one of the Casio calculators, it actually has the log button over on this one. For the Texas Instruments, the log button's over here on the left with the log. For these, it's over here on the right. If you hit the log button on the Casios, it actually gives you the upper part of the problem and the base. So you can actually go back in and put the 2 for the base, just tab over to the 16, hit enter, and it punches everything in for you. So again, different kind, and I think there's some of the Texas Instruments will do that. I just don't have the model that does that because some people showed me that one. But that's one that you can kind of that right with it. So as long as you know how to use it, that's fine. If you've got the silver Casios, it should be in the same location. It's just, they're all kind of similar when you go through those. All right, so example 2, just kind of keep it on that same track there. Let's say you've got 3 to the x plus 4 equals 27. Okay. Now again, the easy way to do this one is if you don't have 3 to a power that's here, we're going to turn around and rewrite this. So we're going to have log of, again, the base is 3, so they stay the same, and then just switch where these two numbers are. 27 goes here, and then the x plus 4 will go over here. All right, and then again, you're back to your calculator now. So log of 27, again, just make sure you close that off, divided by log of 3. That comes out to be 3. So now it's just 3 equals x plus 4, minus 4 on both sides. So x winds up being -1. Okay, so the other day we had to kind of think through the process of going through the powers of this number that would equal this. As long as you know the change of base formula, you don't have to do all that. You can just work through the numbers and basically just rewrite it. And that way, once you've got it rewritten, then you can figure out, whatever the problem may wind up needing to be. Actually, hang on. Make that, sorry, 4 to the 3x equals 64. Okay, same thing. Rewrite it in log form. The base was 4. Switch these two numbers. We've got log of 64 base 4 would equal 3x. All right, and again, there's where we get to use our calculator. So we've got log of 64, close it off, divided by log of 4. That would be 3. And with 3 equal 3x, just divide both sides by 3, so then we get x equals 1. Okay, so all the problems that it's going to come down to this way. If you get it here and you're not able to do this number to this power, because some of the problems we had before, it would work out that way. But if it doesn't work out that this number and that power are there, just rewrite it in log form, and then you get to solve it from there. Just so that when you're doing some of these, you might get some parts of this that look a little weird. So let's take the exact same problem that we had here and make it look like this. All right, so let's say we've got 4 to the 3x equals, in this case, 1 over 64. All right, still going to stay log base 4 when you switch these two numbers. It's going to be a fraction number at the top, which is still okay. Just looks a little funny. All right, when you go to plug that one in on your calculator, you've got the fraction part that's here. When you do the log here, you just need to take instead of being the number, it's 1 over 64, so just do 1 divided by 64. So even if it's a fraction number, when you're plugging it in, just make sure you put it around parentheses and it's still okay. And then do divided by log of 4, and that comes out to be -3. Okay, and then take -3 divided by 3, so then that x comes out to be -1. Okay, so just realize that answers can be all over the board. They can be fractions, they can be whole numbers, they can be some negative numbers mixed in here and there. It just depends on the numbers that you're given when you go through these. All right, here's the very first one where you get something that's a little bit different. And I think we had some of these that we did earlier, and I think we may have already gone through the process of doing this one. But all these, technically, if we back up for just a second, we could have taken this problem and had it rewritten that if we did 3 to the 3rd power, that would equal 27. So what we could do then, and again, this is the thought process they would want you to do, just like on the first problem, that if 2 to the x is equal to 16, well, 16 is the same thing as 2 to the 4th. And if you can take a problem and get it rewritten where the bases are the same, you can just get rid of the bases and then solve the equation that you have left over there. Same thing here. We've got 3 to the x plus 4. Well, technically, 27 would be 3 to the 3rd. And once the bases are the same, you can basically just kind of ignore the bases and just solve the equation for what's there. And then we get back to the answer we've got here. Same thing with this one. 64 would be 4 to the third power. Again, bases are the same, so we can scratch that out and just solve the equations. Then we're here. So that's the way they would tell you to do this. Because a lot of times they'll say don't use a calculator, which means they want you to rewrite it with the bases the same. Basically, they're saying you can use a calculator and get the same answer. They're just asking you not to. They want you to think about changing the same bases. But honestly, once we know the calculator shortcut, it's a lot quicker to kind of go that route with it. Most people prefer it that way. All right, but here's one where you're not able to rewrite it. This is where they kind of, I think we may have done a problem like this the other day. Maybe like 2 to the x equals 14. You go through the powers of 2. There's no way you can take 2 to a power and get to 14. Just not going to happen. So this is one you have to rewrite this problem to get the correct answer. So rewriting it, log base 2, we're going to switch up where the 14 and the x are. All right, and then as soon as you do that, well, now we can use our calculator to get that answer. So it's log of 14 divided by log of 2. Comes out to be 3.807. Correct. And I looked through some of the homework. Sometimes they tell you to round it to 1 decimal place. Sometimes it's 3. Sometimes it's 4. Some of the problems that the answers are big, they'll tell you to round off to the nearest whole number. So it just kind of depends on what they ask you to do and where they're asking you to go for these. All right. They may also give you some where you may have a little bit more in your exponent to work with. Maybe that you have 3 to the x plus 2 power equals 17. Right. And again, there's no power of 3 that'll get you to 17. 27, yes, but 17, no. So this one, you only have one option. You have to rewrite this problem. Rewrite it to log base 3. And again, switch these two up. The 17 goes here, and then the x plus 2 would go there. All right. And again, this goes with the calculator. So you're going to do log of 17 base 3. Just log of 17 divided by log of 3. That is 2.579 if we round that off to 3 decimal places. Now, it's not just x anymore. It's x plus 2. So then your next step is you have to go back and subtract the 2. But again, if you've got the answer in your calculator, just minus 2, and now it's going to be 0.579. Okay. Now, I have seen it, and I don't think it happens this time, but I have seen some books that they would tell you for this answer, sometimes they would tell you to leave this thing in log form. To put this answer in log form basically would be this, where we were doing log of 17 divided by log of 3. Again, I don't think this is the case. I don't remember seeing any of these. But some of these, sometimes they would ask and tell you to put it in log form. So you would go ahead and do log 17 divided by log of 3 equals x plus 2. And then you would subtract the 2 from both sides. Okay, so that was one that, and again, I don't think I flipped through the homework and looked. I don't ever remember seeing one that said to do it in log form. Hopefully they won't ask that, but if they did ask you to leave it in log form, you basically would leave it like it's log 17 over log 3. And then because it was plus 2, you would just do that number minus 2 to get the x back. Okay, so there's all the different ways where you've got a number that's in exponential form. Now we're going to go back and look at where it's in log form because we're just going the other direction now. All right, so let's say you've got the log of 2x equals 1. All right, and for a problem like this, there is no base. So what's the base supposed to be? What's understood to be? Not 1, but 10, right? We got 10 figures, so we always go base 10. All right, so 10's not there, so just remember that one's understood to be a base 10. That way, when you rewrite this problem, your base will stay the same. And again, you switch these two numbers. So now it's 10 to the first, and that's going to equal 2x. Well, 10 to the first is just 10. And then 10 divided by 2 means that x would equal 5. All right, so for this one, let's go log base 3. 2x plus 1 equals 2. All right, and you can pretty much do this, and this was, I think, why most people like doing it this way, was that anytime it says to solve it, now occasionally they might give you like log 3 and then log 2 and then give it x over here, but pretty much every time you've got a problem and ask you to solve it, you've got to rewrite it the other way. That way you don't have to think about it. You just know, all right, I've got it here, I've just got to rewrite it. So base is 3, we move the 2 over here, and the 2x plus 1 goes over here. And then from there, it's just a regular solving equation. 3 squared is 9. Subtract 1 off both sides. Eight equals 2x. So then we take 8 divided by 2, so then we get x equals 4. Okay, now let me show you one more like that, but the answer is a little bit different because we don't have anything with decimal fractions. So let me show you one more where we've got fractions or decimals in the answer here. All right, so let's go with log. Let's go with base 8. We'll make it 2x minus 1 equals 1/3. Okay, same thing as the other ones here. The only way you could solve this one is if they gave you like log of 2 and the base was 8. That one you could punch it straight in the calculator, but because of the x that's here, we've got to take this thing and rewrite it. So this becomes 8 to the 1/3 power equals 2x minus 1. All right, with 8 to the 1/3 power, if you don't know how to do that on a calculator, let's show you real quick. Do the 8, and again, the rooftop or the arrow button that's here, that's your power button. And the only thing for that one is if it's a fraction, you just got to put it in parentheses. So do 1 divided by 3 in parentheses, and that'll make it 8 to the 1/3 power. And that's 2. Okay. And then from there, just regular solving equation, we'll add 1 to both sides. So that's 3 is equal to 2x. And then divide both sides by 3, that means that x would be 3 over 2. Okay, and they should tell you whether to leave it in fraction or decimal form. So a problem like that, when I looked at them earlier, I think that one they said to leave it in simplified form. So that one you could leave it there. If you put that answer and it counts it wrong, try the 1.5 and then, go from there. If that's a test question and you put 1.5 instead of 3.2, let me know because it's the correct answer, just not in the correct form. So we'll go back and give you credit for that one because occasionally that does pop up every now and again. I had somebody on the last test that they did the same thing. They put 0.5 and the correct answer was a half, and I was like, Yeah, you got it. It was fine. So we had to go back and give him some points there. All right, now here's the toughest ones. If you can get these two, this is as bad as it gets when we go through everything. So say you've got log of 35 minus the log of 8x equals 1. Okay, the big difference on this one is we always had one log expression for the other problems we're doing. This one's got two log expressions. So if you start a problem off and there's two log expressions, you have to condense. You got to condense it down into one. So that's just like we were doing Tuesday. We took all the log, we were doing expansion and the condensing properties, and we were doing the log properties, and I was trying to be funny, that they were, round and they were made out of wood, and, you build houses with that kind of thing. Not though this was the actual properties, the multiplication and the division and the power properties. So this is one where you got to condense it back together. So because this being a minus in the middle, that means it's 35 divided by 8x. If there had been a plus in the middle, it would have been 35 times 8x equals 1. Okay, and there shouldn't be, in the problems that we're doing here, there shouldn't be a whole lot of condensing of those. It should pretty much just be either turn it into a multiplication problem or you turn it into a division problem based on what that sign is going to be. For this problem, again, you've got to remember that the base is 10. So once you've condensed it down to one log expression, now you can turn around and rewrite it back to exponential form. So it's going to be 10 to the first power, and that's going to equal 35 over 8x. Okay, 10 to the first power, no problem there, that's 10. So you've got 35 over 8x. Now, this is a part where it gets a little difficult because x is on the bottom, which messes things up a little bit because we're always used to having x on the top when we solve these. If x is on the bottom, there's one easy way to fix this. Just put the 10 over 1, make it so you have two fractions. And once you have two fractions, then you just do cross products. So it's 10 times 8x and then 35 times 1. Okay, so x on top, it would have been really easy. If x had been up here, we'd have multiplied by 8 and we would have divided by 35. This one, with the x being on the bottom, it's almost really kind of backwards when it comes off of it. But the easiest way to do that is just, again, to put this number over 1, make it so you have two fractions, and then you just do cross products. All right, and then from here, divide both sides by 80. So x is 35 over 80. They're not going to ask you, I don't think they're going to ask you to simplify that one. That's one where they're going to tell you just put that answer in decimal form. So do 35 divided by 80, and that comes out to be 0.4375. All right, two more problems, and then we'll wrap this thing up. And I think I'm going to go just to a new page here. All right, so let's do log of 2x plus log of x equals 11. In this case, we're going to go base 3. Okay, same setup as the last one, but the difference is in this case, there's a minus in the middle. So when you condense these two things back together to make it one log expression, that's going to make it 2x times x. Which means that's just the log of, I'm going to put this over here so we got a bit more room side to side. 2x times x would be 2x squared. Okay, so we've got it back to one log expression. Now we get to rewrite it. So it's going to be 3 to the 11th power equals 2x squared. Okay, now, and I don't know what 3 to the 11th power is. There's a lot. I can do some powers of 3, but I cannot do 3 to the 11th. So 3 to the 11th power is 177,147. All right, kind of a big number, but here's what we want to do, because this is, again, this is the whole point of doing this one, is that you've got calculators to help you out. If we're going to solve this equation once we're here, we've still got to get the x squared by itself, so we're going to divide both sides by 2 to cancel this one out. So just leave that number there, divide it by 2. That's 88,573. Okay, and that equals x squared. And if you remember, to get it from x squared down to x, we've got to square root both sides. All right, now the easy way on, and again, every calculator is a little bit different. For this one, you have to get the square root first, and then you put the number in. To do it backwards on this one, to get to here, you can go ahead and use your power button. It's here. And if you remember that very first day we were going through those, that basically, the opposite of x squared, well, here's what we do. Just take 0.5 for the power. That if you take the square root, that's the same thing as raising it to the 0.5 power. So if we'll just take this answer, raise it to the 0.5 power, that's going to square root it for us. And I think on all these problems, it's going to tell you to round these numbers off to the nearest whole number. So we'll say that's going to be 298 for the final answer there. Okay, but again, so that one's got 2 steps with it. Number 1, condense it down so it's down to one log expression, then rewrite it. And that's when you definitely need a calculator, because the work you're going to do there, you're not going to be able to do that in your head. You're going to have a calculator to kind of walk you through that problem. All right, one more last one, because this is one that popped up in the homework and the number got really big, and I didn't mean for it to. I'm going to see if I can change that, but I may not be able to because somebody's already started the homework. There's nothing I can do on that one. Okay, and it looks a lot like the last problem. It's log of 4x plus log of x equals 9. This one we started off with log of 2x plus log of x equals 11. This one's in that same boat. Same thing here. So go ahead and condense it back together. So that's log of 4x times x equals 9. So that's the log of 4x squared equals 9. But what's the base? Base is 10, right? There's not there, so we've got to go back and do that. Once we rewrite this problem, that's going to be 10 to the 9th power equals 4x squared. All right, and if you do 10 to the 9th power, that's barely going to fit on the calculator. That's a 1 and 9 zeros behind it. So you're talking about a billion on this thing. And sometimes, especially that it doesn't have all the commas in here that you can put for this one, if you went back and did this, basically you'd say that's a B. It's almost easier to write out. That's a billion, because you got 1 and 9 zeros equals 4x squared. All right, and again, this is one where you definitely want your calculator here. Same setup. It's a billion equals 4x squared. We're going to divide by 4. So we can get it down to x squared. So now instead of a billion, we've got 250 million. Again, just writing it down just so we can kind of see it. But I would say this would be one you probably really wouldn't want to write this problem down. Once you get to here, you really don't want to write this down because you'll lose track of the zeros. I know I would. It's 250 million equals x squared. But again, you've got to square root both sides to get it down to x. So we're going to raise that to the 0.5 And now we've got an answer we can actually kind of work with. That's 15,811 rounded off to the nearest whole number. All right, now somebody may be asking if you're going back to when we were doing, I think, radical equations last week. They were like, okay, but if you remember, somebody may be saying, but didn't we always do the plus or minus when we did the square roots on these? We did. Technically, we should have put x was equal to plus or minus the square root of 15,000. Well, that number's when we square root it. That we're supposed to put that. But here's the thing with these problems: if you put in a negative number in for the log, just make it small to start with. If you do log of -2, it says no, you can't do it. So just like last week when we were doing the radicals, that if we had the square root of a negative number, or if we had we were doing radicals. What were we doing? What was it, radicals? Yeah, we were doing radicals. If the number inside the square root was negative, it messed things up. This one's kind of the same way, that if you do log of a negative number, that's outside the domain. Log always has to be a positive number. So on these, we don't even worry about the negative answer because that's going to mess things up. So we're only going to worry about the one answer that's positive because that's the only answer that's going to fix these. Okay, so we don't have to worry about the whole plus minus like we did in problems past. This one, we're going to worry about just the one square root that would be the positive answer to get us through.